Alright, so this sketch was created to help the students get a better understanding of derivatives graphically and how the tangent line is related to the derivative, how the derivative is related to the original graph. And so hopefully this ties that concept together visually, which is very helpful in calculus. So let's just quickly take a look. So right now this is what they'll see. They will see nothing, and they'll give them a list of things for the students to go through. So what they're going to do, they're going to click on each of the functions to the left, so right here, individually, and then click the start button. So let's start with quadratic. And so I'm just going to hit the start button and see what's happening here. So this is the point on the graph, and this red dot is, as you can see, the derivative point. It's kind of hard to see. You can easily just zoom in, zoom out. Derivative point. I'm going to move this for now. So we can see, well, as you move it, the function is traced. So the derivative function is traced here. This is derivative point as the point on the curve moves and the tangent line. So we can see here the relation between the derivative point. So we can stop it at any point here, and we can find a relationship between the derivative point and the tangent line. So we see that the slope of the tangent line is our function value of our derivative point. So let me start it again. All right, we also see that the derivative of this function is 2x, and it forms a linear function. Some other things to note are whenever the function is decreasing, we can see that our derivative values are negative. When it's increasing, our derivative values are positive. Something else that students will discover in this sketch. So it kind of gives them some questions to go through the sketches, just kind of discover these concepts and these relationships within our functions and derivatives. So we can just select, you can see our slider is still going because we never hit stop, and that's not a problem because we can just hit cube root and automatically stop. We can see what's happening with our tangent line. We can see this interesting property. We want to zoom in a little bit. Once this tangent line turns vertical, we can see what's happening there. Looks like our values are getting closer to infinity. Okay, and then let's take a look at the exponential. This is interesting too because it happens that the derivative and the function are the exact same thing. So it's a good thing for them to see that graphically. And then I also added the second derivative in green, and we can see how it also traces over the original function, so we can see how it stays the same. So let's look at a rational function. We can see this interesting derivative point, the second derivative. So here's our second derivative as well. So we can see the second derivative has similar attributes to the original function, but the first derivative all stays negative. So it's another interesting thing to see to have the students figure out why that's true. All right, absolute value. This is another interesting one. We have the sharp turn. We can see this discontinuity here in our derivative. Therefore, we know the derivative does not exist at this point here when x is -1. So another thing that the students will discover, we can see the second derivative here. Obviously just going to be 0, but it still has that discontinuity at x equals -1. Okay, and then g of x, which is this cubic function. It's just regular cubic, nothing special. We can see that the derivative is quadratic. But to take the absolute value of that same function, we got a lot of sharp turns going, so we can have the students just see all those discontinuities in our derivative. Same thing with the second derivative, you'll still have those discontinuities, but it'll be linear. So hopefully the students will get a good understanding, hopefully you get a good understanding if you're watching this, that of the derivative, how the derivative function, why the graph of the derivative looks the way it does, why it goes from positive to negative values, why it's 0, why it's 0 right here whenever the function, the slope of the tangent line is 0. So it shows some interesting attributes of our derivative.